Hello and welcome to CS 61A, CSM Week 6, problem number 2. Here we want to draw an environment diagram that results from running this code right here. So we will start with the global frame as always. And the first thing we see in this code is the function reverse with the argument list being defined. So the first thing we want to write is reverse and have it as a pointer to the function. And remember, we have to write what the parent frame is. So parent frame is global because to refresh our memories, remember that the parent frame is always where the function is defined. And in this case, reverse is defined in the global frame. So parent is equal to global. And remember, we don't go inside of this reverse function until it actually gets called. So we skip over these lines for now and we go to the next line, which is a list is equal to this list right here. So list and pointer to a list with 3 elements. So 1, and then pointer to our second element, which is another list with the elements 2, 3, then 4. Next, we go to rev is equal to reverse list. So now our function is being called. Since rev is a variable, I will write that in our global frame and then leave it blank for now because we don't know what the function returns until we actually call it and try it out ourselves. So now reverse is being called, and remember when we call a function, we always want to open up a new frame. So F1, then reverse. Again, parent is equal to global, and I will abbreviate that to P is equal to G. First thing we want to look at is what is being passed as the argument of this function. In this case, the argument name is list, and this list is this list right here. So since they're referring to the same object, we want to have this list point to this. All right. Next, we will go through this if statement. As we can see, the length of this list is not, it is in fact greater than 1. So we don't return list, and we go to this next line. This next line is actually has a recursive call. And since it's a recursive call, it is calling this reverse function. So again, we do not know the return value. So I will write return value, but I will leave it blank for now. And because we are calling this function reverse again, we will open up a new frame. All right, this time, let's see what the argument that we just passed into is. So the argument here is list that is sliced from 1 to the end of the list. When we look at what that is, we see that this is index 0, this is index 1, and this is index 2. So we want index 1 to the end of the list. So that makes it a 2-element list, with the first element being another list that is 2, 3, and the second element being 4. Remember, when we slice a list, we create a new list. So this list will not point to an object that we already have, but it will point to a new list that has 2 elements. The first element is this nested list, which is 2, 3. Then the second element is 4. And recall that we draw a pointer to this 2, 3 list because of the shallow copy concept, where we are slicing a list, we create a new list, but all of the objects that are pointed to in the original list are also pointed to in the new list, and we do not create new objects for these objects that are pointed to. All right, now we go through the if statement again, and it says if length is length of list less than equal to 1, then return list. Again, that is false. So we go to the next line, which again has a recursive call. So I'll write out return value, since we don't know what it is yet. And I will open up a new frame for reverse again, since reverse is being called. All right, so once again, we go to the beginning of the function definition, and list will now be sliced index 1 to the end of the list that we just looked at. So that's this right here, but index 1 is this. To the end of the list is just this lonely 4. So this list is now a pointer to a list with only one element, that is 4. All right, so now we go into the if statement, and we see that list is in fact less than or equal to 1. The length of list is in fact less than or equal to 1. So we return this list right here. Now that we finally have reached the base case, we can go back up to the previous frames and actually fill out these return values. So let's go back to this F2 frame. And when we look at the return value, we want to return what we just called plus list index 0. So again, this has a plus, it's adding two lists together. So when we are adding, when the syntax looks like this, we create a new list. So here we will, this return value will be a pointer to 4. Then we are adding the list index 0. And here you can see that list index 0 in this frame is this list 2, 3. So the second element will be a pointer to this. Okay, so now that we got the return value of frame 2, we can go to frame 1 and get the return value of that. Okay, so this is getting very messy, but again, we will have to create a new pointer because we're doing the same thing where we are adding two things together with this notation. So we are adding this to index, and after that, we are adding index 0 of list, which in this case will be this index 0. So let's do that. We have 4. Then as our second element, we again have a pointer to this list. And then for our last element, index 0 of list was this. So F1. Now finally, we can know what rev is. So rev is what was just returned in frame 1. So rev is a pointer to this list. So ultimately what rev is, it's this. Rev is this list right here. And you can see this has done what the function intended you to do, which was to reverse our list that we inputted. So the list has been reversed.